Um, for those of you who joined us last time, welcome back. And for our new participants, welcome to the second half of our lunar surface science workshop on science accomplished with a robotic arm. We have an exciting, busy morning, late morning or early afternoon for you, depending on where you are. So thank you all for joining us. And our plan for today is, so Shaun, my co-chair, and I will give you an introduction and summary of the content that was submitted over the last few weeks. For those of you who submitted, thank you very much. This isn't your only opportunity to submit this content. We will continue to encourage you to submit information as it arises if you're so inclined. But yeah, so today, I guess we'll go ahead and dive right in because I don't want to take away from our opportunity for discussion. So again, so the plan for our first 15 minutes this morning is to reiterate the goal of this workshop and provide a summary of the submitted content. And then I'll discuss the plan for today's discussions and breakout sessions. And then again, like I just said, invitation to continue submitting templates as ideas occur to you, and especially if the discussions today give you some inspiration, we encourage continuing submissions on that. All right, so as a reminder of what we're trying to accomplish here today, so the point of this workshop is to identify science use cases and related capabilities that a robotic manipulator should have to address the key science objectives that we want to achieve on the lunar surface. So going into this workshop, I had identified 3 primary science use cases identified for a robotic manipulator, robotic arm. Those are surface analysis, using the arm to put instruments or tune instruments onto a specific sample or target on the surface and analyze those samples in situ without acquiring them. Then there's sample collection or sample acquisition to acquire and transport the samples, whether that's to deliver samples to on-rover instrumentation for analysis in place or to sample stowage containers that could be then returned to some sort of return opportunity. And then the third use case was instrument deployment, so transport of instruments from a payload deck and delivering them to the lunar surface. And then we had encouraged people to identify any other additional use cases that we weren't covering in case we had missed anything. And then the key questions that we had identified last time as to what we want to consider going forward and what we were encouraging as part of our submissions was what are the key science objectives that are achievable using a robotic arm? What types of samples are needed to address those key science objectives? That's particularly the case for sample acquisition and sample collection. And then what types of arm-mounted and deployable instruments tools are needed to address these key science objectives? So that's all really on the science side and instrumentation side. And then what are the arm capabilities that are needed to achieve those key science objectives? And with that in mind, we did ask for the input for you. So we provided you a template with a list of key parameters that we were looking for. And it didn't have to necessarily be tied to a specific instrument, although specific instruments were welcome as well. But just kind of to get a blanket understanding of the enveloping requirements that could drive arm designs going forward as technology advances and is established. So over the last couple weeks, we did not give you very much time for this. This was a rapid turnaround request. So we did receive 14 responses. So thank you all to those of you who did respond. And we're just showing you the breakdown just so that you can see what was submitted. The use cases identified were pretty much spot on from a science perspective. So instrument deployment, we had 3 submissions of instruments that could be deployed by a robotic arm. Surface analysis received 5 inputs. Sample acquisition received 1. And then for the other category, we didn't identify any new science use cases, but there were 4 arm design templates that were submitted, and one for a hardware control unit. So basically commanding instruments across the arm. So those were also included as responses received. But what I want to highlight this morning in particular are the science, the science part of the story, because that's really the key part of what we're trying to get out of these discussions is what's the key science that we can get using, and or what's the key science that we can achieve by using a robotic arm, and then again, what are the requirements of the arm to achieve these science objectives. And so part of our discussion going forward is going to be identifying these, discussing these science objectives in particular. So the four, or the, I guess the out of the 14 submitted templates, these were the science use cases or science objectives that, the science objectives that were identified as what would be achievable with a robotic arm. And they can be kind of grouped into, the familiar suspects, the produce subsurface maps of regions of interest. So, for example, identifying suitable habitat locations, or also mapping the location of water-rich deposits up to 8 meters below the surface. So clearly, subsurface mapping is a key objective of science, and these are objectives that could be achieved using instrumentation on a robotic arm. And then assess composition and distribution of volatiles on the surface with and other ISRU targets. This kind of overlapping with the last water-rich deposits as well. Like quantify volatiles in situ to understand volatile loss on return samples and conduct in situ microanalysis of major elements in mineralogy. And then provide unique in situ measurements for rock soil characterization, enhance understanding of near field regolith properties, and iron bearing mineralogy, as well as the iron chemistry in rocks and regolith, magnetic properties, and particle sizes of mineral phases, and then geomechanical properties and thermal properties of soils in the lunar regolith. So those are really the key science objectives, and then and there was one also. So those are the key planetary science or lunar science objectives, I should say. Then the next couple that I have listed were on imaging and sampling capabilities. So those were also identified as objectives, as kind of supporting the achievement of science objectives. And then the final one on here is looking at the structure, formation, and nature of dark matter and early dark matter, so an astrophysics related science objective that was identified as being achievable with a robotic arm on the lunar surface as well. So that's the spread of content that was submitted. That's not to say that these are all that can be addressed. And so that's one of the key discussion topics that we're going to tackle today is identifying additional science objectives and diving down deeper into some of these as well to make sure that the arms, that the enveloping specs for the arms can achieve this, the objectives, the key science objectives that we're addressing or identifying here. So before I continue, I wanted to see if Shaun had anything he wanted to add as far as the submitted content or the templates that we received.
Sure, yes, thank you, Debra. Yeah, as Debra mentioned, we've received a total of 14 responses, and we're especially looking to draw out. We know that we only received one use case that was associated with sample acquisition, and so we're definitely looking to get more input in that type of application. We want to make sure that we cover the full range of applications that are out there, and make sure that we have better knowledge going forward as we define the specifications that we need for robotic systems that can support those. So, that's the focus of these breakout sessions is going to be to brainstorm and generate input, but then also maybe to kind of seed or spark some ideas with folks and get some more template submissions so that we can make sure that we're covering the full range of use cases.
Excellent. Thanks very much, Shaun. Yep. And so talking about the breakout sessions, so what we're about to do is to go ahead and split into those breakout sessions. There's 3 that we've identified, again, tied to the use cases. So the surface analysis will be breakout session 1, sample acquisition, breakout session 2, and instrument deployment will be breakout session 3. Those links, if you registered for the meeting, because you have this link, you should have registered in the same email. There are links to those breakout sessions that we'll be breaking into shortly. The plan for our discussions, we have, again, the questions that we identified that will be identified or will be discussed in each of these breakout sessions include what are the science objectives achievable, and what instruments are needed or what instruments are needed to address the science objectives, and then what do you need from the robot, from the arm, to make the instrument work, and in particular, how precise do those services need to be? So for example, if you need to have contact with the surface for your instrument to work, how precise do you need to know what that contact pressure is? And we might not be able to have really quantitative answers to some of these questions. Some of them might be, we need high precision at this time, and maybe go back and get more information and bring it back. But we do want to get as much input as we can to help the engineers building these arms have as much insight into what we need as scientists to achieve the science objectives that we're identifying. And then sample acquisition will also have a question about what types of samples you need, like size. You need a full rock, do you need a powdered sample, do you need regolith, that could be particle sieving, size sieving, and stuff like that. So that will all be addressed in the discussion. We're trying something new today, so I'm going to stop sharing this and go to another screen. So bear with me while I switch over. We are trying something new today to encourage broader participation. It's one of the key things we want to be sure is we're doing is getting as much input from as broad a sector of the community as we can. And we understand, these virtual workshops are sometimes difficult to have that communal input. So what we're doing today is we're going to have links to these Jamboard sessions, and we'll put them in those chats of the breakout sessions, so you'll have access to them. And just briefly, what we'll do is we'll have a question that we pose, so the science objectives. We'll ask you to come over here. It's on the left side of the screen. It'll be the 4th icon down is a sticky note, and you can click the sticky note and say, you type in, what your objective is, and you post it, and then you can, move that sticky note onto the screen. So that's going to be your input. We encourage, as brief as possible. If you start doing paragraphs in these sticky notes, the text gets pretty small, but do include what input you have, and everybody can be doing this at the same time, basically. So if you have something to say, please put it on the screen. We're going to do that for about 2 minutes, and give people have that kind of non-verbal input, and then after that we'll have a more traditional discussion that's guided by the input that we have on the screen. You're welcome, of course, during the discussion. If you have inspiration and something else occurs to you, you can always add another sticky note. But yeah, so that's what we're going to try today to help guide the discussion and help document what people's ideas are, even if they're not speaking at the same time. And then there might be an opportunity for you to vote on what your favorite science objective is. There will be a couple options for this. One breakout room might have a series of circles on the bottom of the screen where you can pull up the circle and vote on it. Or others might take the approach that you can take the pen to the first tool on the left and just draw a line. And if everybody's doing this, please, for ease of counting, every fifth person do the slash across so that we can count easily. Okay, so that's the plan for the breakout sessions. There are a number of questions. We allocated an approximate time for each discussion topic so that we can, wrap up within an hour and a half of our allotted time. And then after that, we will return. I'm going to switch back to my presentation now. We will return to the to this room here for outbriefs on what was discussed at each breakout session, and then a general discussion to close out the workshop. Okay, with that, I'm going to pause. So what we're going to do at this point is now's the time to break out to our breakout sessions. I am happy to answer any questions that you might have on the process, but because we're going to have this, the discussions, of course, in the breakouts and then a general discussion at the end, I'm going to ask that you hold out on content questions until that general discussion at the end. Okay. Thank you Ricky for putting the breakout links in the chat. So everybody, please do that. All right. Are there any questions before we?
Just a question of clarification. Are we answering the common questions in each of the breakouts, or are there specific questions we're answering within each?
So these common questions will be answered in each of the sessions.
Okay, understood.
Yeah. So if you join one, you'll have access to that the Jamboard in that particular session.
Okay, but kind of in the context of the breakout.
Yes.
Got it.
Exactly.
And please, Fanny, you just joined by clicking on the link that takes you there, or you have a separate way?
Yes, I believe you should be able to access each breakout session by the link in the chat.
Okay.
Deborah, you have a question. Are you going to share the results in the breakouts?
Yeah, so the outbriefs are intended to summarize the content that was discussed in each of the breakout sessions. So that's the plan, is to have each breakout session give an outbrief of what was discussed in there during their breakout. Thanks, Ryan. All right. Hopefully everybody's made their way over. So I will go ahead and join my breakout room. I'll see you on the other side.